Hello guys, welcome back to the channel. In this session, let us see the second example on projection of straight lines. The question is something like this. A line AB 80 mm long is inclined to HP at 30 degrees and inclined to VP at 45 degrees. Draw the top and front views of the line and determine their lengths. Also measure the perpendicular distance of end B from both HP and VP. Now, let us make a note of what are all the data given in the question. Initially, they are telling there is a straight line 80 mm long. So, time being, I will call this one as 80 mm straight line. Theta is equal to 30 degrees and the angle phi is equal to 45 degrees. So, with these two minimum data, we are supposed to determine their lengths. Apart from that, also they have mentioned to find the perpendicular distance of B from both HP and VP. So this is the frame of the question and these are the things we are supposed to find out. Now let us break down the data one by one. We are supposed to find out their lengths, means it is understood that their apparent lengths. The apparent length A dash and B dash in the front view and AB in the top view. If you want to find out the apparent length, means we are supposed to find out apparent inclinations. That is nothing but the angle alpha and the beta. Alpha will be the front view angle and beta would be the top view angle. We wanted to find out the apparent length, means it's very clear that the given distance, the given initial distance should be the true length. If this is true length, means that given two inclination should be equal to what we call it as true inclinations. So these are the first thing we are supposed to break down. Theta is given as 30 degrees. This is angle with respect to HP, and phi is equal to 45 degree. This is with respect to VP. But very important concept in engineering drawing is any inclination with respect to HP. I repeat, any inclination with respect to HP should be drawn under VP and any inclination with respect to VP should be shown under HP. Now, let us go to the solution. I will make use of grid sheet for this purpose. The grid sheet clearly says that 1 unit is equal to 10 mm. The first thing is, let us draw the XY line. So try to keep the minimum thickness for XY line. Let us mark this as VP, this is HP. So what is this representation? So this indicates that the projection of planes is in the very first quadrant, that is above the horizontal plane and in front of the vertical plane. Now let us go for the dimensions straight away. What is the angle? 30 degrees to HP and 45 degrees to VP. Just now we have mentioned 30 degrees to HP should be shown under VP and the vice versa. Now let us make use of protractor here. Take any convenient point just for representation purpose. First let us take 30 degrees to HP. I repeat, 30 degrees to HP should be shown under VP. Make the same point as the reference. Let us mark 45 degrees. From the point of consideration to 45 degree line, let us draw a thin line. It is confirmed that this length is the true length. But what is the distance of true length? It is 80 mm. I will make use of compass and I will measure 8 grids, 8 square blocks from this grid sheet. Else we can go for 8 centimeters from the normal scale. So with this measurement, keep the compass needle here and cut an arc at a distance of 80 mm and cut one more arc towards the other end, that is on 45 degree line. Now we got the end point of this true length. Let us make use of scale and draw an imaginary line. Big line, small line, big line, small line, big line, small line. Let us follow the same step here as well. So this is what we call it as locus line. Similarly, this is also called as locus line. But how do we differentiate the two locus line? This is the locus line of point B in the front view and this is the locus line of point B in top view. Now If these two are the locus of point B means where is the initial point of these two? Obviously this should be the initial point. Let us call this point as A dash and this is the point A. Now where is the locus of point A? The XY line itself is the locus, but we need not mention it. So this is XY. I will tell you the small procedure how to obtain the solution. Not only for this particular solution, you can follow this method for all questions while solving in projection of straight lines. Whenever you are having a true length has to be projected. Then rotate the true length, we will be getting the apparent length. Once if I got the apparent length, I can find out the apparent inclination. Now make use of scale where exactly the endpoint B lies. The endpoint B lies somewhere over here. I will drop a perpendicular. Let us go for the projection. But the question is, where do we stop? Please stop at the opposite locus. This is, we are starting from a point B. Stop at a point A. Drop a perpendicular. Make use of compass for rotation option. Point A dash and A as the center. This point as the radius. The new point what we got now. This point as the radius. Construct a simple arc. Draw an arc in such a way that it intersects with the previous locus what we have drawn. The true length is projected and rotated. What should I get now? Apparent length. Now don't you think the arc what it is drawn here, it is intersecting the locus line here. So the locus line intersection and the initial point, now that should be the apparent length. Apparent length representation is extremely important. That has to be increased in its thickness. Follow the same procedure the other side. Make use of your scale. Here we are having a true length. True length has to be projected upwards. Let us make use of compass. Point A dash as the center and the new point what we have got as the radius. Let us construct an arc. I repeat, this is a true length. We have projected upwards. We have rotated. Now I should get the apparent length. So this is the frame of the solution, but let us name it one by one. We are supposed to find out the apparent length A dash B dash in the front view, AB in the top view, one by one. I'm having a point A dash here, its corresponding apparent length end point. Now this point should be the B dash. Similarly, I want to find out AB. A is point here and corresponding apparent length in the top view. So for all your understanding purpose, this is the front view representation, this is the top view representation. Already it is mentioned. Clear? Okay. This is the point B. Now coming back to the true length. What is true length? True length is 80 mm, right? So true length will be A dash B1 dash in the front view, A B2 in the top view. So this is A dash and the corresponding true length will be B1 dash. Here A and this is B2. So B2 if you are projected upward means when it is moving towards the front view, this would be B2 dash. B1 dash when it is projected downwards, that is when it is coming towards the top view means, so this point will be B1. So downward arrow mark, let us show the downward arrow mark, the flow of lines. So this moves in the upward direction. So this is the upward arrow mark. What are the dimensions here? What is it we are supposed to find out? That's important, right? This portion of the angle we need not find out. Why? Because it is already given it as 30 degrees. Even this portion of the angle we are taken for consideration. It is a part of the data. This is nothing but 45 degree. The only thing is now we are supposed to check out the angle apparent inclination, what we call it as alpha here. We want to check out the angle beta. Just make use of protractor. Let us find out the angle. We can clearly visualize here the angle alpha is reading as 45 degrees and the angle beta is reading as 55 degrees. Actually, we are supposed to find out their lengths, that is the apparent length, and the perpendicular distance from HP and VP. As per the question, they have not asked you to find out the value of alpha and beta. Alpha and beta we are doing actually, but what is the apparent length? A dash, B dash and AB. Now, how do we find out the value of A dash, B dash, A and B? Place a protractor at a point B dash, mark 90 degrees here. Let us mark one more 90 degrees here. That is from the point A. Make use of scale. Extend the line, dimension line. From this point we can extend one more dimension line. Draw the dimension line something like this. If we measure the distance between two, it is showing somewhere around 5.7 centimeters. That is nothing but it is 57 mm. No need to write it as mm. Mechanical standards or mm. Now follow the same procedure other side as well. Place a protractor on point B, the end point B. Mark 90 degrees here. Similarly at a point A, mark 90 degrees. So this distance is close to 69 mm. Now let us add one more dimension in the similar fashion. Place a protractor on B1 dash, mark 90 degrees, one more on A dash. Extend the line of action for dimension line, extend the line of action for the dimension line. Now these two should be already we have taken, that is 80 mm. So now this completes the solution. How do you show it as an answer? So give all the answers in this box. The first thing is the apparent length. So what is the value of apparent length? A dash B dash is measuring as 57 mm. In the top view, the value is equal to AB, that is measuring as 69 mm. Also, we are supposed to find out the perpendicular distance from HP and VP. The last part. What is the perpendicular distance from HP and VP? Make use of scale here. This is the point A, these two are the point B. Check out what is this distance now. And let us check out this distance as well. So this is the perpendicular distance. So if you measure this one, so this is 10, 20, 30, 40, close to 40, 41. I will take it as a 41. And this is 10, 20, 30, 40, 50, 55. So close to 55, and this is 56 mm. But how do you write this one? So this is the first part of the solution, and the second part of the solution is the perpendicular distance. The perpendicular distance is, this is 41 mm above HP. You can use the full form, clear? And 56 mm in front of VP. So this is the end of the solution. Yes, we have done everything, but what is the conclusion, that what is the proof that the solution is right? Please make sure that make use of your scale. Keep the scale at corresponding endpoints of the apparent length, that is B and B dash. If the 2 points lies on the common straight line, that means to say that the problem is correct. The solution what we have obtained is correct. Hope you have understood. Hope you have enjoyed this video. If yes, give this video a thumbs up. I request you to share with your friends. I will talk to you in the comments. Have a nice time. Bye.